Hello. Okay, let's go over this next calculating acceleration task. So you should have read this. This is going to be really important today. So I'm going to start for us. To solve for acceleration, we're going to follow these steps. The next thing that we should actually do is make sure that we have the correct units for acceleration. So the unit, I'll add that in for you, is meters per second squared. And I'll add that in for you in your classwork as well. So this is also in your reference sheet here. So this is also going to be very important. These are 3 different ways of how to calculate acceleration. Actually, this is one way. It's just written in a different way. So change in velocity over change in time is the same exact thing as this. What this triangle is here, that's a delta, and that means change in. Okay, change in velocity, change in time. So when we say change in velocity over change in time, that means we're taking the difference. For example, this one right here and this one right here are exactly the same. This one is just a more broken down way of saying it for writing purposes. The change in is the difference in the final velocity and the initial velocity. Final means the ending, but we're going to use final. That's why I wrote it down for you, and we're going to practice using that term because that's the more appropriate way of saying it. And then the initial is the starting. How it starts, some will only say like starting time or at rest or from stationary, and that just means that it's a 0, okay? But this will be given to you today in this class. So we've already learned how to calculate acceleration from a given velocity and time, but what if we weren't given the velocity and weren't given the today we're going to be learning how to do that because prior we weren't given the velocity and time, we were just given the acceleration. For our egg drop experiment, we're going to need to calculate acceleration before determining the force exerted by a vessel. And I'll break down for you how to do that as well. So some vocabulary you should know are velocity and speed. These are going to be used interchangeably, meaning that we're either going to say velocity or speed, depending on what we're talking about and what we know. So if we say velocity, that means that it is an amount of time, a distance covered over a certain amount of time, but including its direction. That's the main thing. That's the main difference. Speed is still the distance over time. Okay. So we're going to be using these interchangeably. If I say one instead of the other, like that's the same thing. So velocity is not exactly the same as I told you. It has a direction. For example, 15 meters per second, that is the speed, or velocity. It's a speed, but 15 meters per second north is the velocity because it has a direction. You can calculate acceleration of an object from its change in velocity and the time taken. So acceleration is the change in velocity represented by this delta v, which is also here, divided by the change in time represented by delta t, which is here. So I'm going to demo for you how to complete your tasks, and then you're going to go give it a shot. Philip Q is traveling in a Maserati. The velocity changes from 1 meter per second at the top of the hill to 6 meters per second by the time he reaches the bottom. So if it takes him 5 seconds to reach the bottom, what is his average acceleration as he races down the hill? Well, you already know how mass affects the time, right? So the heavier the object, the heavier the object, the less time it takes to drop. You saw that in your space video, you saw that in the parachute thing. Well, here, there's other components, there's other factors at play. It's not just time. So that's why we needed to break down time, because we are also going to break down acceleration for you and velocity for you. We'll break down velocity later on in these lessons. So what you need to do is write out the equation. Acceleration is change in velocity and over change in time. All right, so you can write down this relationship. When I say relationship, you're going to need to write down the equation. So this is like the relationship, because an equation is showing a relationship. So you can write it that way, or you can write it this way, or you can write it this way, either way. I wrote it this way for ease. Now, what are we looking for? What is the average acceleration? Well, we are looking for acceleration, so we would type that in here. Is it not letting me type? Okay, cool. Well, anyway, we're looking for acceleration. The cool, you should write this neater than me. And what are we given? Well, we are given, let me see, identify a circle velocity and time. So velocity changes from 1 meter per second at the top of the hill to 6 meters per second. And the time he reaches the bottom, it takes him 5 seconds to reach the bottom. Okay. So what's the average? So what are we given? We are given velocity changes from 1 meters to 6 meters. So this is the starting, which is the initial. Tag it VI or starting. I'm going to do a VI because that's in my thing. And then that's supposed to be an F. And then this is the VF because that's my final velocity. That's what I'm ending with. So we know the 1 meter per second is the VI. And we know that 6 meters per second is the VF. And then we also know the time, which is 5, is that time. Okay. So for total time, it can be, it's the same thing, final minus initial, but it gives us the total time anyway, so we don't have to worry about that. And you won't have to worry about that in experiment. Okay, so now that we have, what we're looking for is acceleration, so based on that, we are doing the acceleration equation, and then we're given final, initial, and time. So now we can plug it in, as it says, plug the values into the formula. Okay, so A equals V final minus velocity initial over time. So that means that acceleration is going to equal VF, which is this guy right here, 6 minus VI, which is 1, over total time, which is 5. Okay, 6 minus 1 is 5, and then over 5. 5 divided by 5 gives us 1. Okay, 1 meters per second. Don't forget the unit squared, and I'll add that in so you won't forget it. Go ahead and box your answer because that is your solution. All right, you're going to solve each and every one of these like that. The relationship will be given to you since we're just doing acceleration today. And now let's move on. I'm going to demo how to do one thing in task 2. So task 2, this is more difficult than task 2 because it's a word question. So this one's super easy. We're solving for acceleration, so all you have to do is write down that formula, final velocity minus initial velocity over time. So let's plug it in. Acceleration equals final, which is 24, minus initial, which is 0, over time, which is 3. Okay, so 24 minus 0 is 0. Sorry, guys, I need to put my phone on silent. Thank you. 0. 24 minus 0 is 24, sorry, over 3. So what is 24 divided by 3? You should get 8. I'll write it here. 8, don't forget the unit, meters per second squared. Okay, awesome. Awesome. So make sure that you do that. Make sure that your units are correct. There's the first part of your task 2. That's all this. And then from there, you're going to do the word problem just like we discussed about. Okay, cool. Thanks.